In this video, we're finally going to add some specular lighting or specular highlighting onto our Raymarched sphere. Now it's really starting to look like we have actual shaded geometry in Unreal, but really, even though we can move around this object and it seems fully 3D, if we view the wireframe, it's really just a cube with a material. So we're doing this object as a fully Raymarched sphere. So it's just plotted pixels based on the camera position. And we're also calculating diffuse highlighting, which we previously did in the video before. And in this video, we're going to add that bright highlight here, that bright spot that we see highlighted on the peak of this lighting for the sphere. And this is going to give us the illusion that the light source is reflecting off the object or highlighting it. It also gives us the illusion of how rough or how sharp or smooth that surface is. If the surface is really smooth, it's going to be a smaller highlight. If the surface is really rough, we're going to fake that by adding a larger highlight. So this highlight will be controllable. But let's look at how we can add this specular shading or highlighting to our Raymarched sphere. So this is what we should have from the previous video, and really all the adjustments that we're going to make to add this specular lighting will be done through our code. So I'm going to jump into Visual Studio Code with the code from our previous video of where we left off, and what we're going to do is start adding what we're going to need to add to produce that highlight. So the very first thing that we're going to want to do, we've already calculated the normals of the surface, we calculated the diffuse lighting. What we're going to do now is calculate the reflection. So we're going to do float 3 reflection, and we're going to make that equal the reflection or reflection vector from the light direction and the normal. And that's it. And that's going to be the reflection vector of the light direction and surface normal. And the surface normal we already defined up here. So that's all we're going to do to get our reflection vector. And then after that, what we have to do is use that reflection vector as a way of getting the view direction, and then using that view direction and doing a dot product of the reflection vector and that view direction. So it sounds a little bit complicated, but we have our reflection vector. What we're going to do now is get the view direction, and then we're going to do the dot product between those two and use that to get our highlight. So the next thing is we're going to add a float 3. That's going to be our view direction, and that's going to be the normalize of the world position minus the ray origin. And it's going to be the normalized vector from the world position to the ray origin. And there's going to be a bit of a problem with this, but I'm going to go over that in a little bit. And after this, we're going to do our specular results. So our specular will just be a float, a single value. 1 if it's a strong specular, 0 if there's no specular. So it's just going to be a single value. And that specular will equal the power. And we're going to max our dot product of the reflection and the view direction that we just specified now. And that is pretty much it. So if we do that, we'll then max this so it can't go below 0, so you don't end up with negative values. And then we're also going to do it to the power of something like 16. And that's it. And that'll be our specular value. And this will control the amount that we put the power to, like the exponent of the power, will be the control for how big that highlight is. So that's pretty much everything we need to do. Now, the only thing we have to do is now add this specular contribution into our resulting pixel. So before we returned the diffuse multiplied by our surface color, what we're going to do now is our diffuse multiplied by our surface color, which we already have, and then we're going to add our specular highlight on top. So we're going to add our specular highlight times, and then the color that our specular highlight is going to be. So we'll just make it white, since that's going to be the specular highlights in real life for mostly everything that's not a metal or not some sort of special material. Most objects have a white specular or a full wavelength for their specular highlight. And that's pretty much it. So that's all of our code. Now we get our diffuse and our diffuse color. So it's like the color of the surface times the strength of that color. And then we add on our highlight strength multiplied by the highlight color. And if we take all this code, put it into Unreal, you may think that it's done and everything's good, but let's see what happens when we update our code here with that new adjustment. Okay, something very strange happens. Our highlight is in the wrong position. Our highlight is down here and not here where it should be. And remember in the previous video how we made some adjustments to the code. For example, we inverted the ray origin, multiplied the ray step by -1 to properly get our light and our sphere center translations working properly. Well, the same problem's happening with our specular highlight, because if we look back at the code, when we calculate our view direction, it uses the world position. And nowhere else are we using the world position aside from through the ray origin where it's already being flipped or inverted here. So we just have to make this negative world position minus ray origin, and that will fix everything. So we're going to go and make sure that our float 3 view direction is negative world position minus ray origin to flip it the correct way. And if we take all that code now and just update it, very small update, then our highlight's in the correct spot. If we change our light position, so if I look at the axis down here, X is this way, Y is this way, Z is up and down. So what if we make our light direction now negative X and negative Y? That means the highlight and the light should be coming from this angle. Let's go do that adjustment. So -1X, -1Y. Does that work? Yes. Now our highlight's that way. And if it's +1, it'll be the other way. So that's all working good. Our highlights all being drawn correctly based on where it should be. And if we save this and use it in our scene, it's really starting to feel like we have a fully shaded 3D object now. But again, it's really just a cube in this case. And if I apply any sort of object, it could be a cone, pop on this material. Oh, it's a sphere now. So it's really cool. You could do a lot of neat things with these shaders. And of course, if that shape cuts it off, then it's going to have a little bit of a problem. I have to scale it up a bit. But it's really cool how we're able to do this. So what comes next, now that we have some shading working, and if we want to change that highlight, we can always make additional controls here and work them into your code. But right now, if I go in here and change that specular to the power of 16, if I make it to the power of 256 and I save that, then we get a really nice sharp highlight that can make the object feel more smooth, more glossy. So a lot of adjustment here that you can make and start working into your code. But now we have something that works for drawing our 3D shapes. Next, we're going to take a look at how we can add displacement or animated movement to these 3D shapes, to the lights illuminating them, and also how we can make different shapes as well. If you enjoyed this video, if you learned something new, make sure to like this video, subscribe, press the bell button for notifications, and check out the Patreon in the description down below. And if you are part of the Patreon, again, you will get this PDF that goes over this video lesson as well and has all the steps that we went over as a way of just quickly referring to those steps if you forget them. It also goes over one little extra thing that we didn't talk about, which is how to add ambient lighting. So if the shadowed area is too dark, what it's going to go over is how you can add some ambient lighting to this object as well.